Good morning, good afternoon, good evening. This is Mrs. Wormley doing part 2 of this foldable. We did standard form. You should have all of these notes. And we learned that standard form, the easiest part about standard form is that it tells us our y-intercept. So that's why we really like standard form. We graphed this by doing this example over here. I gave you this equation, and then you identified A, B, C. We wrote our y-intercept down, so we graphed that, and then we figured out axis of symmetry, gave us this so that we knew this is axis of symmetry here. It's also the x value of the vertex. We plugged that x value and the vertex in over here, and now we simplified and we got this as our y value, and there we go. So we're going to do now the vertex form. And the vertex form is what you've been exploring with if you've been in my class, where you were trying to see what are the shifts by adding one or subtracting one or in the parentheses, out of the parentheses, all that. So vertex form, we're going to formalize it right now for you. It's f of x equals, and it's a, same a value as in standard form, same a. And then it's parentheses x minus h squared plus k. So it's x minus h squared plus k. That's the format, that's vertex form. And we're going to use that now to be able to tell us all kinds of stuff. And this is probably the easiest format to graph from because it tells you the vertex and you know the a value, and you can use that cool pattern I showed you from the last video. So I'm going to open this up now, move it over. So with this, if you remember in class, that we were shifting our parabola left, right, up, down. And a lot of you realize that if you have outside, you have x squared, and you add something to x squared, that made it go up and down. So that was our k value. So that was telling us what our y was. It made the vertex go up, it made the vertex go down. And then when you subtracted or added in the parentheses, it made the shift, left or shift right. And so our axis of symmetry is actually where a vertex is moving left or right. It's that x value. So our axis of symmetry is found by looking at your h value here. It is x equals h. Whatever this value is right here, that's going to be your axis of symmetry. But you have to be careful because the format is x minus h squared. If you have x minus h squared, if it's in this format and you take out that number, your h is a positive number. So if it's x minus h squared, this value of h is positive. If you have x plus h squared, then h is a negative value. And that's why we saw that when you subtracted from x inside, it shifted to the positives because h was positive. So our vertex is shifting to the positives. And if it was plus inside, it went to the negatives, it went to the left because it was a negative value. And the reason why here is because if you have, and I'm going to put this like little side note thing, if you have an x minus a negative number like that, what's really happening is when we're subtracting a negative, add the opposite. That's what goes to this x plus h. We're adding the opposite. So subtracting a negative is adding a positive squared. That's why. So if you have this, then we know that h is negative. Okay, that's just a little reminder down here for you. Okay. So axis of symmetry is whatever you find h is. If it's in this traction, if it's x minus h, we know that h is positive. If it's x plus h, then we know x is negatives. That's why we said if it's subtraction inside, it goes to the positives, to the right. If it's addition inside, it goes to the left, to the negatives. Your vertex, this is why we like vertex form so much. Your vertex is just the point h, comma, k. And we use the same idea here with our h. So in this case, it's minus, so whatever this number is there, forget that minus sign for a second, whatever that is, and that's your vertex. Just like that, you pull it out of there. This tells you what your shift up or down was. That tells you your shift left or right. and you're good. So maybe I'm going to write that on here. So H was your shift, either left or right, because that's your X value. And this is your Y value, so your K, let's do an arrow this way over here. Your K was your shift up or down, because that was the Y value that you were changing. So those are really important parts to our vertex form. Your A value, again, is just your dilation. It's your second difference. And we're going to use an example where it's not 1 to see how we do that, how we graph it. So the last box that we need to fill out is more important information, and that is what our A value is. So if we have a positive A value, then we know that this opens up. And a lot of you realize that hey, if A is positive, it's going to face upwards. It's going to open up. And if it's a negative A value, then it opens down. So it's going to go like that. And then, something else a lot of you noticed when you were playing around with it, I said I want to make it narrower or skinnier, or we call that having a stretch. And if you, whatever this A value is, if the absolute value of your A is greater than or bigger than 1, then we know that it's narrower, or we can call that has a stretch. It's like something is coming and stretching it to make it narrower and taller and longer. So I'm going to write my 1 that way so you can tell it's the number 1. So that would be like if that was a 3 or a 5 or a 1.2, whatever the absolute value is, positive or negative, it's going to tell us what our stretch is. If it equals 1, then it's going to be a regular stretch. There will be no stretch. It'll be this normal, as we call it, the parent graph opening at that point. If A is between -1 and +1, so we put it like this, -1 is less than A, but A is less than +1. In other words, your decimals or your fractions, then it's going to be wider. And we call that a compression. So it's like it's squishing something together, and it's going to make it a little bit fatter or a little bit open up wider. So narrower is a stretch and wider is your compression. So skinnier, fatter, if you want to think of it like that, opens up faster, opens up narrower. So this will be like itty bitty up like that or like that. And this wider is going to be more like that. These are your dilations, or like that, for you visual people. Okay, so what we did on the last one was we highlighted important information that's really helpful. And for the vertex form, all of this is really helpful. Vertex form is the easiest form to graph from. And now you're going to learn how we can go from the other two forms to vertex form. So I'm going to have all 3 of these are highlighted. And that's why we spent so long last week and this week on vertex form. You really have to understand it. Okay, so now we're going to do an example for our graph. So I'm going to slide over here, and we're going to draw a line where we had that last graph, and we're going to do another one here so we stay within the lines for this example. And our example now, we're going to have an equation. It's f of x equals -2 is going to be our A value. And then in parentheses, I have x minus 2. And then we're going to have that squared and then plus 3. And so I'm going to use my pencil again like I did last time. So I'm going to look at this and define everything that I know. So I know that my A is -2. That's right here. This is x minus h. So because it's subtraction, I'm going to go back over here. It's x minus h, so I have a positive h value. So this is a positive h. So positive 2. And then my k value is whatever that says. So it says plus 3, so it's a positive 3. If it said minus 3, it'd be a negative 3. So whatever this operation is actually the same sign as that number. So I have plus 3. So those are my 3 important parts. So this tells me, because it's negative, that it's going to go upside down because it's negative, and it's going to be narrower because it's greater than 1. The absolute value of negative 2 is positive 2, so it's going to look something like this. Skinnier than it would be if it was x squared, and it's going to go upside down. And hk is my vertex. So I'm going to put my vertex equals hk, so 2, 3. So I already know my vertex, which means my axis of symmetry is just going to be 2. So I can put my axis of symmetry is 2. And now I'm going to start graphing. So I'm going to go to my vertex first. So my vertex, this is my origin, over 2, up 3. That's my vertex. And I know it's going to go down. So I'm going to put this as my vertex. And then it would be the points 2, 3. And it's going to open down, which means that, and it's an a value of 2. So over here on our standard form 1, remember I said from the vertex it's over 1 up 1, over 1 up 3, over 1 up 5, and that'll give you in the table, this is actually your first difference right here, which means that your second difference would be plus 2, which is why your a value is half of that as 1, making some connections from module 1. And so now my a value is 2, so I double everything. So I'm going to go over 1, and it would be down 1 if a was 1, but I'm going to go times 2. So 1 times 2 is now down to 2 right here. Then I'm going to go over 1, and it should be down, it was over 1 up 1, over 1 up 3. So this would be over 1 up 1, the times 2 is 2. This is now, should be 3, but I'm going to do 3 times 2 equals 6, and this equal 2. So down 6. 1, 2, 3, 4, 5, 6, right here. So over 1, down 2, over 1, down 6. And if I had to do the next one, it'd be down 5 originally, times 2 would be down 10, like way down here. So I'm actually decreasing much faster than I would have if it was 1, because I would have had over 1 up 1, or down 1, over 1, down 3, would have been here, so it would have been a much smoother curve, narrower, or wider. And now this is my axis symmetry, is right through my vertex, so I do the same thing on this side, over 1, down 2, over 1, down 5, and I honestly just look to see where was it, I make sure I have over 1, and there you go. That is graphing with the vertex form. We know our vertex was here because of our equation. We knew that our a value was negative 2, so we opened down, and we went down at a faster rate because that was a negative 2. So that is it for graphing with vertex form. You're going to have a worksheet now that you should have gotten in class that looks like this, and it's all on vertex form. And so the vertex, you have, this is what our parent function was, and how was it translated? So what happens here? You're subtracting after the x squared. So we know the vertex you can figure out, and if there's nothing in there, then it's x minus 0 squared minus 5. So your vertex is 0, negative 5. And the graph was shifted. Blank units, okay? And so did this shift left or right at all? That's a 0, so no. So this shifted 5 units, and we can say down because that's a minus 5. And our vertex is right here now. And so you're going to do the same thing on all of these. And so this again now it's going to be plus 5. So same vertex form. So you're going to write it in vertex form if it's not already, and you're going to do that. And then and this goes all the way down, lots of transformations. Remember, you can use Desmos if you need to remind you. Fractional a value right here, greater than 1 a value there, negative goes upside down. And then you're going to flip it over and you're going to graph. There's vertex form. Remember, if it's minus 5 squared and there's nothing here, it's really plus 0. So what's the vertex? You can get that from there now, and you're going to graph it. A value is 1 because there's nothing there. And then here, I give you the equation, you can find the vertex and write the equation yourself. Same thing, and one more. So you're going to practice these at home after you're done. And this is what you're going to return back to me, is this page and those. All right, that's it, guys. See you in class.